let's do some very basic caps lock division. Yeah. I'll start from a clean slate. I want to head over to here the print hex 16. I have a working bit of code that adds an ASCII offset and prints a character. Let me just add that in there so I can print stuff to the screen. So let's get a value happening in there. Move AX, let's say 20. Alright, and then that will be our dividend, the number we want to divide. And then after that, we'll just move into BX, the number we want to divide by. That would be our divisor. There we are. So now that we have those numbers loaded, all we need to do is call divide BX. There we go. However, let me just save that and run it real quick. That don't print nothing, and the reason for that is we also need to initialize DX there. Make sure that that DX register is cleared. So let me save that and see what we got now. 4. Okay, what does that tell me? That when I'm done here, I am returning and then doing it all again. Oh, gotcha. Yeah. So that means I need HLT. End of program. Let's see. What do we got there? Nothing now. Why is that? What did I do? I didn't call any of this. Okay, so now I have the value loaded. I can call you. Yeah, let's see what happens. There's my 4. Yeah. Calling the ASCII offset. Good. Okay. So now let's say if instead we'll go divide, have a number that doesn't divide evenly, right? Say. Okay, we still get the correct value there, except we don't have our remainder. To get to that, let's see, it is stored now in DX, which kind of comes back to the reason we wanted to have a look at that. Okay, so we've called our ASCII offset. Let us now, AX is all free, so I'm just going to put a value in there for our decimal, like that. Okay, and then this time, now if I call ASCII offset, that's the value I actually want to print, right? So I don't want to add an ASCII offset to it, or I'll get something else entirely. All I need to do now is call that. Yeah, okay, so, and then once I'm done with that, let me move AX DX there. Okay, so now I want to print DX where my remainder is stored. So I'll just move it into AX and call this again. Oops, 6. Did I not save or something here? Let's see. I did not save. I still didn't save. What am I doing? Control S. Thank you. 6.2b. Okay, what is going on here? I called this twice for one. There, 6.2. There you go. There's our there's your answer, and the remainder remainder as well. Quotient. Yeah, sorry. My quotient and my remainder. There's your simple division. Next, let's say, well, if we have 5 up here in the dividend and 10 in the divisor. Let's see what we get here. Yeah, you get 0 for your quotient, and then the dx will contain the remainder there. Okay. Next, let's deal with a much larger number. I'm going to put, like, say, 1,000. Up in there. And say, well, divide that by 25. Wonderful. Okay, so what happens? Well, we got the right number. The value's in there, but we can't read it. Why is that? Because we've been putting off dealing with printing out decimal values for far too long, and apparently the time has come. If we ever want to make a Pong game with a score that goes over 9, this is just one of the hard facts of life we're going to have to face, I guess. So we'll do that next. Fortunately, we're going to use a bit of division in that, so now we got enough basic division under our belt where we can accomplish that. See, we had a conundrum. We couldn't do the one without the other, and then we couldn't do the other without the one. Okay, but we got far enough in where we have a basic understanding and can proceed to being able to do that. Now, basically, we want to take our big values, say 65,000 or whatever, and you divide it, and here, we want to just print this big number, right? So you can think of it as an iterative process. We're going to see if the value is 10,000 or greater, and if so, then we want to grab that out of there, and then print that, somehow. And then we'll see if it's greater, if it's 1,000 or greater. See, and then you check if it's 100 or greater, and then is it 10 or greater, and then is it 1 or greater, right? And then when you get to 0, you've reached the end of when it returns nothing there, right? Okay, then, so that's a kind of iterative process, right? Meaning, you could do a check, do a subroutine. Is it this much? Then do this. And then another subroutine that says, is it that much? Then do that. But as we can see, well, we can't because there's things in the way. There we go. 10. There. If we took that and then just divided it by 10, and we got that, see, and then divide that by 10 and divide that by 10. That's where the division comes in, because that allows us to make an iterative loop instead of having to make 5 separate if statements, essentially, to deal with each one. Okay, so we will do that in the next video.